Hey class, this is Mr. Roberts, and I guess kind of a student request. Couple people came up, and I just want to make sure that we understand exactly what's happening here. So, we understand that the equation of a line, any line with one notable exception, vertical lines don't quite fit this pattern, but the equation of a line can be written in a form using this, right? Y equals the slope parameter times x plus the y-intercept parameter. So that slope parameter is represented by m, and remember that's the vertical change divided by the horizontal change. So it's that rise over run pattern. And b is that place when x is 0 and I'm crossing the y-axis. Right, we call it our y-intercept. So find the equation of a line in that form. And there's other forms we'll deal with, but right now we're looking at this. So let's consider this. Let's say that I've got this. I want to be here. I've got this set up in Desmos, but there's 2 points. And I can see if I click these points, I can get their coordinates. Here's point 1, and here's point 2. And I want to come up with the equation of the line that will perfectly hit those 2 points. Now, the first thing I want to do is I want to think about what's the slope, right? What's the slope? And I'm going to write those down right here while you're looking at it. Maybe you can write them down on your paper too. But the 2 points I have are 3, 12, and the other point is -4, 1. So here they are. I think I wrote them down. 3 positive 12, right? X is 3, Y is 12, and -4, 1. And I'll just go back and take a look at that again, right? There it is, 3, 12, -4, 1. All right, so what I want to do is come up with the equation of the line that goes to those 2 points. And I'm going to start that process by figuring out what the slope is. So in order for me to calculate the slope, I have to remember what it is, right? And there's a lot of ways of saying this. But the slope is essentially how much does your y value change divided by how much your x values change, right? What's that ratio of change in y over change in x? And for convenience, I'm going to underline, here's a y value from this point. Here's the y value for this point. You don't need to do this sort of thing. Here's the x value, right? Here's the x value. So if I want to see how much the y's change, I'm going to look at the purple ones. And I can do this one of 2 ways, right? I can, for example, I'll go 12 minus 1. So one way to write this is 12 minus 1. 12 minus 1. But I could also write, and I'll do this over here, 1 minus 12. Right? It's gonna look different, but at the end, it's gonna look the same. So that's how much y's change, right? 12 minus 1, 1 minus 12 is an alternate way of writing it. Now I'm gonna look at how much x changes. So for the 12 minus 1, I'm gonna go 3 minus -4. 3 minus, and then a -4. 3 minus the opposite of 4. And going the other way, I could write -4, -3. Okay. So 12 minus 1 is just the number 11, and 3 minus -4 is the number 7. And if I look at this alternate way, this line here, this alternate, 1 minus 12 is -11, right? And -4 minus 3 is -7. But sure enough, when I take -11 and divide by -7, I still get my slope is positive 11/7. So either way you do it, you just have to be consistent, right? So if you start at this particular point, right? If you start at this point and you go this way, you have to go the same direction for the y's. So if I'm going from the first point to the second, I got to make sure I'm doing the same thing with the y's. All right, so I found my slope. My slope is 11/7. Now, just for fun, I'll go back to Desmos. Here I am at Desmos, and I'll just type in y is equal to 11. Whoops. Oh, that's difficult. I know why it did that. 11, got it, divided by 7, and then I go plus, well, no, and then I'll do x. So y equals 11/7 x, up 11 over 7. And actually, I could see this if I'm at this point from here, right? At this point, I can go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then over 1, 2, 3, 5, 6, 7. So 11 sevenths. Okay, so I now know the slope. I'm pretty convinced this is the correct slope. What I need to figure out now is where my y-intercept, right? It's some number like in a certain range in here, right? But you need to figure out that number exactly. So how do we do that? Well, there's a lot of ways, and I've gotten a lot of good advice from you guys over the last couple of days of how to do that. But I'm kind of settling in on this thing, this one idea. Although I'm tempted. I'm tempted by some of your offerings, but this is where I'm settling in. I'm going to start with this relationship, right? I'm going to start with this y equals mx plus b. And I'm going to consider one of the 2 points I had. And for me, I'm just going to select this point where x was 3 and y was 12. And remember, my slope m is the number 11 sevenths. So if you think about this, if with this point that I have and the slope that I found, I have an x value, right? 3 is an x value. I have a y value, and they go together. That xy pair goes together, and I have a slope. So look, I've got an x, I've got the y, I've got the slope. The only thing that I don't have in this case is I don't know what the value of b, my y-intercept, is. So this is how I can set out to find that y-intercept. I'm just going to simply write y, and this time playing the place of y is the number 12. I'm going to sub in 12. Oops, let me grab the black pen. I'm going to sub in 12 for y. So I got y equals m. 11 sevenths is my value of m. 11 over 7 is m. So I got y equals m times x. Well, x is the number 3, right? So I've got my value of x, and then plus b. So my whole strategy here is I just need to solve for b. I just need to solve this equation for b. And to do that, I'm going to multiply 11 sevenths times 3. When I do that, I get 33 over 7. 12 equals 33 over 7 plus b. Well, it looks like I would know my y-intercept, but I just need to subtract 33 sevenths from both sides. So I'm just going to go 12 minus 33 sevenths, and that's what b is, right? On the left and the right-hand side of that equation, right, the one above it, I subtracted 33 sevenths. So you can see that the 33 sevenths on the right-hand side went away because there's no 33 sevenths on the right-hand side now. And on the left-hand side, I now have this negative 33 sevenths. So let me go to my favorite calculator. Where's that at? No, here. This is good. My favorite calculator. Right now, it changes, right? I've owned a lot of calculators in my life, but I'm going to enter 12, and then I'm going to subtract from that 33 sevenths. So I enter my fraction template, 33 over 7, and when I do, I get 51 sevenths. I would have never guessed that, right? I mean, how would I have guessed that number? So my y-intercept is 51 sevenths. So I'm going to go ahead and just write that down, right? B, this value of b, is 51 divided by 7, 51 sevenths. So now that I know both my slope and my y-intercept, I can write the equation of this line. The equation of this line is y is equal to m, my slope is 11 over 7, times x, and then plus b, which is 51 over 7. So if we go back to Desmos, we can see, can we? Yeah, Desmos. There we are. No, I need Desmos. There it is. We can see this. So what I'm going to do is, instead of just stopping here, I'm going to add to that plus 51 over 7. So you can see, you can see I got it, right? And in fact, what's really nice is if I zoom in a lot on one of these spots, this point is not going to deviate from this line, right? I can keep zooming in again and again and again. But this point is on that line. This point is a solution to this equation. If I was to plug in the x and the y value from that point into the equation, it would make both the left and the right-hand side the same value. So my solution, my equation that goes through the two given points is y equals 11 sevenths x, and then plus plus 51/7. All right. So reality, sometimes we have fractions, right? Sometimes they're not perfect, they're not pretty, they're not nice little numbers, but I don't know, 51/7, 11/7, it's some sevens. One of the ways we can also write this equation, oh, are you going there? Yeah, I'm going to, is standard form. And standard form actually, in this case, I think it would probably look better. For me to rewrite this in standard form, I would multiply both sides by 7. So on the left-hand side, 7 times y would be 7y. On the right-hand side, that 11/7 x would just become 11x. Plus, and when I multiply this by 7, I get 51. So you can see I don't have any fractions now. And then standard form, normally we have the two terms with variables on the left-hand side. So I think I would write ax, let's see, I think I'd write negative 11 times x plus 7y equals 51. So I'm not asking you to do this right now. I just want you to think there's ways that I can manipulate this, write it differently. I'm pretty sure this is what I would call standard form. Although I'm wondering if somehow the coefficient of x is supposed to be positive. I don't know. I'll call that standard form until I'm told differently. And then this is slope-intercept form. But those two equations, right, will hit that line. In fact, I think Desmos is so amazing that even in Desmos, if I was to switch over there and type in that other equation, right, negative 11x plus 7y equals 51. Yeah, you can see it. When it was plus 5, it was down there, but as soon as I say plus 51, boom, they're the same line. So yeah, this is the two different ways, and it's not the only two ways, right? There's another option, we've got two, but this is the slope-intercept form, this is standard form, and there's more. Anyways, just want to help you make sure you're able to think about this. You know, if we have 2 points, can we find the equation line that hits those 2 points? Yes. It's not easy, but it's math. This is Mr. Roberts. Actually, it's kind of easy. I'll talk to you guys later.